this lesson we're going to have a look at the idea of compound interest, and I thought I'd just illustrate the compound interest like this. If you have a certain amount of money to invest, and we'll imagine that it's that amount of money, and we leave it in the bank for 12 months and it accrues interest, and let's say 7% interest. At the end of that year, there's a certain amount of money you've made in the way of interest. With compound interest, that gets added to this first amount and becomes a bigger amount. So that amount is increased by the amount of interest for the next year or the next time period, in this case a year. So for another year it earns 7%. The interest will actually be more because you started with more money. At this stage, the interest is added to the principal at the beginning of the year, and for the next year you've got a bigger amount of interest. So in other words, you're not taking any money out of the bank, it just stays there and the interest is added to it period after period, so year after year or whatever it is that you're working with. So there's the idea of compound interest. So let's have a look at the definition up here, and we'll just highlight a few points, and that is it's compound interest. The interest earned, this is the key, the interest earned at the end of each time period is added to the principal. That's the main thing. All right, I thought also to illustrate this just once without the formula, this is what we're going to do. We've got $2,000 invested for 3 years at 7% interest compounded annually. It says find the amount the 2,000 will grow to and the amount of interest earned. So what we'll do is we're going to set up a few headings here. We're going to put a heading for time. We're going to have an area for working. We're going to have the total balance. And over here we're going to have the interest at the end of the year. So we'll start off first of all with the start of the first year. So over here we'll write the start of year one. There's no working in this case, and we know that our balance at the start is $2,000. And the interest earned is 7%, so we'll write this as a fraction, 7% of the $2,000, which gives us $140. Now we take that $140 so that at the start of year two, we take our $2,000 that we had originally and we add the interest, as we said in the diagram, of $140, which gives us a total balance of $2,140. And once again, we work out the interest of this, so that would be 7% of our $2,140, which gives us, now some of this will be rounded, $149.80. So let's start year three. Our working would be then our $2,140 plus our interest. In this case we've got $149.80, which gives us our total balance of $2,289.80. We work our interest out on this, 7% of $2,289.80, and that gives us $160.29. So that means that after 3 years, so that the start of the fourth year, sorry, I've put there year four, start of year four, so we actually don't have to go any further than this now, of course. We've got our $2,289.80. To this we're going to add the interest that was earned last year, $160.29, which gives us a total balance of $2,450.09. And so our answer for this question A is that the amount that it will grow to after 3 years will be that last amount, $2,450.09. And the total interest earned, well, if we take $2,450 and subtract from it the $2,000 that we started with, that will give us our total interest for this of $450.09. Now, in the previous section, we had a look at how to work out the compound interest, but we did it in a complete sort of way where we took year by year and so on. Well, in this section, we're going to have a look at the fact that you can do this quickly using the compound interest formula. And here it is here. And let's have a look at the meaning of this. The A here is the final balance or future value. Now, the important thing about this is these two words, final balance or the future value. That will come up later in the course. So that's what we're going to work out, and that includes the amount that we started with. P is the principal, the amount we put in. We call that the present value or the initial value. R is the rate of interest, and this is the compounding rate of interest, and we always express this as a decimal. And N is the number of time periods, and I'll remind you again, this could be years, it could be days, quarters, months, so we need to look carefully and see how this works. We're going to do a quick example of this using the formula and make sure that you can see how it actually does work. So we start with the question, use the compound interest formula to calculate the amount of fixed term investment, $5,000, 5 years, 6.5%, and it's compounded yearly. Our formula is A equal to P 1 plus R to the power of N. Very important that you always write that down. So our P is $5,000. So let's put our $5,000 in here. Now we need our rate of interest. So over here we know that the rate of interest is 6.5%, and as a decimal, if we divide that by 100, we get our number that we're looking for, which is 0.065. You need to make sure you get that right, 0.065. And the time period, it's yearly, and it's done for 5 years. Now you need to make sure you get this in your calculator correctly, because really that's the only mistake that you could make with this, just getting the calculator wrong. But I'm going to put this in, and you'll find that the answer should be, if you check it, $6,850.43. That would be for A. But our question goes on to say, find the total interest earned. So, and this is a common part of the questions that are asked, so that our interest would be what we finally had in our bank, which is all of that amount, taking away what we started with, in this case $5,000, and when we subtract those two things out, we end up with our solution, the amount of interest we earned, $1,850.43. In these examples here, we're going to look at how the formula sometimes needs to be rearranged. Now you'll notice if I write, or let's look at the question first of all. We've got a certain amount being invested for 6%. It's $5,000. That's what we want to have at the end of the year after 4 years. So let's write down our formula. A equals P 1 plus R to the power of N. Now in this case it says calculate the amount that must be invested. We don't know P, so that's the question. What we do know is that we want $5,000 at the end altogether. We don't know P. We do know the interest rate, which is 6%. So we can convert this to a decimal, 0.06. And we know that it's for a period of 4 years. So how do we do this? Well, there's a little bit of, I guess you'd call it algebra involved. If you have a look at this section here, it actually works out to be one number. You can either work that all out and write it out, or probably preferably, to save you the problem of having to round, take your $5,000 and take this whole thing, because this is a times in here, remember, P times that. Remember, in algebra you would divide by this to move it from this side to get P on its own. So we're going to put our bracket here, 1 plus 0.06 to the power of 4, and that will actually give us our value of P. And if you work out this with your calculator, this will tell us that the amount that we invest in order to get $5,000 at the end of 4 years would be $3,960.47. So this is a very good way of working out how much you would have to put away in order to have a future value that you need at some time. For example, it could be you want $5,000 after 4 years for a holiday, but you don't want to be putting money away. If you're fortunate enough to have that much money, $3,960.47, put it in the bank for 4 years. In 4 years' time, you could go away on your holiday because your amount would be there. All right, so that's fine with that sort of question. But what happens here? We've got 7.5% invested. It's compounded quarterly. All right, so we need to know a number of things. The things that we've got to change is the interest rate. So the interest rate is going to need to change. It's 7.5%. We need to divide it by 4 to find a quarterly interest rate, and then we need to divide this by 100 again to get our actual number that we're going to substitute into the formula. So in this case, if you do that, it turns out to be an interest rate of 0.01875. All right, now what about our time period? The time period, the number of times that this interest comes in, N, is going to be 4 lots of, now that, remember, there's 4 payments over 3 years, which will be a total of 12 interest payments. Now with those numbers in mind, we write down our formula again. A equals P, 1 plus R to the power of N. All right, so it says calculate the amount that must be invested. So we've got to find P. We know that we want $1,700. That's what we want. The principal, we don't know. We do now know that the interest rate is 0.01875. We know that the time period of 3 years has become 12 units because of the 12 interest payments. And once again, here we go with that same pattern that occurred in the previous example. This needs to go down to the other side. So let's multiply this out. We've got 1,700. We're going to divide it by 1 plus 0.01875 to the power of 12. And that will give us P. Working this out, you should be able to get the answer, and P in this case should be $1,360.31. So that is the amount of money that must be invested. Now in an exam you really should say, therefore, this amount is the initial, or something like this, initial amount invested. And that will answer the question as to calculate the amount that must be invested.